Okay, welcome back to the discussion for section 6.1. This is the last chapter for this course. So we're getting there, but 6.1 is on exponential functions. Let's take a look at a couple of questions in here. The first one says that we have a function, f of x is 2 to the x. And we want to evaluate a couple of places like f of 2, f of negative 2, f of 0, and f of 1. Right? So each of these we're just replacing the x in the function with 2 or negative 2 or 0 or 1. Right? So for example, f of 2 is the function 2 to the x, where the x is replaced with this 2. So it's 2 to the 2, which is, of course, 4. f of negative 2, same story, but instead of replacing the x with 2, I'm replacing it with negative 2. Anything raised to a negative exponent can go down into the denominator with a positive exponent. So the negative 2 goes into the denominator as positive 2 power. And then that, of course, is 1/4. I won't finish the rest, those are easy. 2 to the 0 is 1, 2 to the 1 is 2. I guess I will finish the rest. I'm not going to write them down though. Let's take a look at the next one, number 5. Number 5 says that I have f of x equals 1/3 to the 4 minus x. Right? And we're asked to do a couple of evaluations here, f of 1, f of 2, and f of 4. So f of 1 is taking 1 and replacing the x in the function with 1, so this would be 1/3 raised to the power of 4 minus 1. Now, there aren't parentheses here, but this exponent is all considered to be inside of its own little parentheses. So as far as the order of operation is concerned, I need to take this operation first. And so this is 1/3 raised to the 4 minus 1, which is 3. So this is 1/3 to the 3. Well, you can treat that as 1 to the 3 over 3 to the 3, or as 1/3 times 1/3 times 1/3. It's the same thing either way. In either case, I'm going to get 1 over and 27. Plugging in 2, same story here. It's 1/3 raised to the 4 minus 2. And yet again, since there's a whole bunch of junk going on up in this exponent, you want to figure out what that number is first before you then apply the exponent. So that's 1/3 to the 4 minus 2 is 2. And again, that's 1 to the 1, or excuse me, 1 squared over 3 squared, or 1/3 times 1/3. It doesn't matter. In either case, we end up with 1/9. f of 4, kind of same story. 1 over 3 raised to the 4 minus 4. 4 minus 4 is again in its own little imaginary parentheses. And so I end up with 1/3 to the, but 4 minus 4 is 0. Anything that's not 0, that gets raised to the 0, is 1. So there we have that one. Okay. Let's look at number 8. It says graph the function, and I have 1/2 to the x. So if you have to do this by hand, it's convenient to just grab a few x values and figure out their y values or their f of x values. Just a couple like negative 2, negative 1, 0, 1, and 2 will work. Right? But if x is negative 2, then y is 1/2 to the negative 2. Having a negative exponent is going to flip everything, so this ends up being 2 raised to the 2, and that is 4. So I have the point negative 2, 4. If x is negative 1, this is then 1/2 to the negative 1, which again, because it's negative, is going to flip this 2 to the positive 1, or just 2. If x is 0, then I have 1/2 to the 0. Anything to the 0 that isn't 0 itself is just 1. And you can see the pattern here. 4 multiplied by 1/2 is 2, multiplied by 1/2 again is 1, multiplied by 1/2 again is going to be 1/2, multiplied by 1/2 again is going to be 1/4. So we can finish this without actually doing the calculations. Or you can do the calculations. If x is 1, I have 1/2 to the 1, and that's just 1/2. If x is 2, I have 1/2 squared, but again, that's just 1/2 times a 1/2 again, so I get that 1/4. So I should be able to graph it. I have plenty of points to do so. I have the point negative 2, 4. So if x is negative 2, y is 4. X is negative 1, y is 2. When x is 0, y is 1. When x is 1, y is 1/2. And when x is 2, these guys went ski-wampus on me here. When x is 2, y is 1/4. And so if you got more values, you would see that this gets closer and closer to 0 on the right. And as we go to the left, it would blow up more and more. Plug in x is negative 3. At negative 3 here, you're going to get an 8, so it's like way up here. And we're just going to get closer and closer to 0, but never really get there as we go to the right. So on the right, we have an asymptotic approach to the x-axis. It just gets closer and closer and closer. And then as we go to the left, it has that exponential explosion. And there's our graph. Okay. Let's look at 9 as well. Nine is the same. It's f of x equals 2 to the x minus 2 though. So I would do the same thing. I'll just grab a couple of x values and find their y values. And I'll start with those same ones, negative 2, negative 1, 0, 1, and 2. And I may have to adjust this to find some better ones, but I think those are probably good for now. But if x is negative 2, then I get 2 to the negative 2 minus 2. And remember, all of this exponent is like it's in its own little parentheses. So this is 2 to the negative 4. I'll figure out that exponent first, and then apply the exponent, but this is 1 over 2 to the 4th. And that's all 1 over 16. Very small number. Okay. X is negative 1 gives me 2 to the negative 1 minus 2, but that's 2 to the negative 3. This is 1 over 2 to the 3rd, and that is 1 over 8. If it's 0, then I got 2 to the 0 minus 2, which is 2 to the negative 2, which is 1 over 2 to the 2, which is 1 over 4. If it's 1, and this is the reason I may have to adjust, because these super small numbers aren't terribly helpful. They're very close to 0, they don't change a whole lot. It's the ones down here where x gets larger that might be a little more helpful to me. But if x is 1, this is 2 to the 1 minus 2, or 2 to the negative 1, or 1 over 2 to the 1, which is 1 over 2. If x is 2, I get 2 to the 2 minus 2, which is 2 to the 0, which is 1. Right? And this is where I start to see that exponential explosion, so I'm going to do a few more. If x is 3, then I have 2 to the 3 minus 2, which is 2 to the 1, which is 2. And you can see the pattern, of course. 1/16 multiplied by the base of 2 is 1/8. Multiplied by 2 again is 1/4. Multiplied by 2 again and again and again. So if x is 4, I'm going to get 4 If x is 5, I'm gonna get 8. Here you can see that pattern. That means most of my exponential growth is over here on the right. If I'm at -2, I'm so small I might as well be on the line, but I'm not. If I'm at -1, I'm again very close to it. At 0, I'm at 1/4, so I'm still pretty low. 1, I'm at 1/2, so I'm getting there. 2, I'm going to be at 1. 3, I'm going to be at 2. And then 4, I'm going to be at 4. And then 5, I'll be at 8, and I see that jump. Now we can see that this is just an exponential of 2 to the x that's just been shifted. It's always the opposite sign, so instead of left 2, it's right 2. And I've just taken all of a 2 to the x and shifted it to the right by 2. Excuse me. All right. Hopefully that was helpful. Thank you, and I'll see you guys for the next time.